our C value is 3, D is equal to 1, and K is equal to 2. Okay? So our X values are affected by K and D. So all of our X values will be divided by 2, and then we add 1. Okay? Because it's X over K plus D. Why would I get blue on my nose there? Okay, so -2, you take that, and you divide it by 2, -1, and then you add 1 to get to 0. Okay? -1 divided by 2 is -0.5, plus 1 is +0.5. I'm going to use decimals here just because it's simpler. Okay? And you keep doing that, so this is 0.75. Okay, then our vertical asymptote, so 0 is multiplied by, or divided by 2, that doesn't affect it, but then it's moved over 1. So our new vertical asymptote is x equals 1, because everything has been shifted to the right 1, because D is 1. Okay, then I have 1.25, 1.5, and 2. Okay, my horizontal asymptote is a y value, so that's not affected by the x things. That's not affected by k or d. So now let's do the y values. So everything's being multiplied by -1, and then we add 3. So -0.5 times -1 is 1/2. 1/2 plus 3 is 3.5. So -1 times -1 is 1. 1 plus 3 is 4. Okay, and you keep going that way. So then 5, skip this, we already did it. 1, 2, 2.5. And then our horizontal asymptote is now going to be y equals 3, because everything has been shifted up 3. Okay, so I like to draw the asymptotes first because it gives me a context of where this is going to go. Remember, this actually has a reflection, so these guys are going to reflect up and down, and then we're stretching them and moving them all around. So it's not going to look this way anymore. The end result will end up looking, well, with something up here like this, and then something down here like this. So knowing the asymptotes first gives us a context of where the points are going to be bunched. So x equals 1 is the vertical asymptote. So again, you do that with a staggered line there, and you label it. And x equals 3 is our, y equals 3 is our horizontal asymptote. Okay, so it's all going to be here and here, or here and here. Okay, so we have 0, 3.5. And then 0.54. And then 0.755. Okay, so here we have some, that's what's happening over there. Okay, and then we have 1.251, 1.52, and 2.5, so this is what's happening there. So I hope you see that without those asymptotes, those points would look really, really strange, and you would kind of be wondering what's going on. With the asymptotes drawn, it gives it a lot better context, and you have a much clearer idea of what the shape is going to look like. So there you go, that's your transformed reciprocal function. Let's do one more, it's an absolute value function. Oh, sorry, I forgot about the domain and range. So remember, domain and range is just relating back to the asymptotes for a reciprocal function. So our domain now is x such that x cannot equal 1. This is a set of all real numbers, and our range is y such that y cannot equal 3. This is a set of all real numbers, okay? It's just whatever the asymptotes are, that's what x can't be and what y can't be. So those are clearly seen in the d value for the vertical asymptote and the c value for the horizontal. Okay, our final example is absolute value. So you can throw in those points there, draw your base graph. Okay, Let's apply these parameters. So we have -3 on the outside, then 2x plus 8 on the inside. So I'm going to factor out k right away, make it 2 bracket x plus 4, and then -1 on the outside of the function. So our a value is -3, our k value is 2, our d value is -4, and our c value is -1. So this is being reflected along the x-axis, stretched by 3 vertically, horizontally compressed by 1/2, left 4, down 1. Okay, so you can do that visually with the points, or you can use the table of values, which I think is simpler, and there's less room for error. So all of our x values would be divided by 2, and then we subtract 4. Okay, so you should be able to fill this in on your own. You're just dividing all these values by 2. So -2 divided by 2 is -1. -1 minus 4 is -5. So you can continue that. -4.5, -4, -3.5, and -3. Okay? And the y values, so we go to our a and our c, are being multiplied by -3, and then subtract 1. Okay, ay plus c. That's how we get that. So -3 times 2 is -6. -6 minus 1 is -7. And you continue that all the way down. -4, -1, -4, -7. Okay? So now you just plot these points. 1, 4, 5. 1, 2, 3, 4, 5, 6, 7. So here's -4.5, -4. Okay, so okay, so notice that this is a stretched out version of what we had before, which makes sense. Okay, so our domain still will be x is any real number. Okay, that hasn't changed, but our range has changed. Okay, now I want you to think about how the range has changed. It used to be greater than or equal to 0. Now it's less than or equal to -1. Okay, so it switched to less than or equal to because the a value is negative. You have to be really careful for that. That's a very common error to miss that. And then the actual value has gone down to -1 because the whole function has been translated down 1. So that is kind of the summary of everything we've learned with transforming parent functions. This is a very, very important part of mathematics in high school if you're continuing with university-bound mathematics and functions and calculus. You will be transforming functions all throughout this year and next year. So please, please, please take the time to understand this, to do it well. Rewatch the examples, try your own, and get comfortable with it because you won't be saying goodbye anytime soon. So thanks so much for watching, and I hope you learned lots.